How do you have a killer app for confidential computing and have that application take off if it's not completely trustworthy and completely seamless to be able to adopt?
We call it confidential computing now. In a decade, it'll just be computing.
Welcome to AI Confidential. I'm Aaron Fulkerson, the CEO of Opaque. This is the podcast where I sit down with industry experts to talk about the promise and potential of AI to create breakout industry leaders or to disrupt the current leaders. After all, whoever controls the data controls the industry. For this episode, I'm really excited. I had an opportunity to sit down with Mark Russinovich. Mark Russinovich is the Chief Technology Officer and Deputy Chief Information Security Officer at Microsoft Azure. Also, who joined us was Mark Papermaster, the Chief Technology Officer at AMD. These are two pioneers in technology and computing, and I've looked up to them for decades. Really, since the beginning of my career, I've known who these gentlemen are. So it was really exciting to have them on the pod. In this episode, we discussed everything from trust and attestation for sensitive data to the innovations that confidential AI can unlock. We even looked into our crystal ball to predict how confidential computing will eventually become the standard across the industry. I hope you enjoy this conversation. If you do, please subscribe to AI Confidential wherever you get your podcasts, and also be sure to subscribe to our newsletter for updates. Thank you for tuning in. So Mark Papermaster, Mark Russinovich, thank you both so much for taking the time to speak with me today. I've known who you guys are for as long as I've been, since when I started my career. I've known of both of you, so it's a real honor that you take the time to speak with me today.
Well, thanks for having us.
Absolutely. It's a pleasure.
And Mark Russinovich, you're the CTO of Microsoft Azure and the Deputy Chief Information Security Officer. You also have authored many books, including 5 novels, which I only learned recently, and I will be reading some of your novels because I read the background on them and they were pretty exciting. And furthermore, you were the creator of Winternals, which were like my favorite nerdy configuration tools for Windows way back in the day. So I give that a shout out because I love those tools. They were fantastic. Mark Papermaster, you have been a pioneer for decades leading technology and computing. You were a leader at IBM. Then you went to Apple, where you directly reported to Steve Jobs while you were responsible for the iPhone and the iPod. And you've been at AMD, skillfully leading AMD into the AI future as the CTO of AMD for the last since 2011, correct?
That's correct. It's been 13 years. I've also had a chance to, over that time to work closely with Mark Russinovich. So thanks for bringing us together with you today, Aaron.
Why don't you guys talk a little bit about your collaboration over the years?
Yeah, well, Mark and I have been working on confidential computing, just in the collaboration between AMD and Microsoft in general, but with a strong focus on confidential computing for many years. Just in terms of a partnership where we actually act in some senses almost as one company working on a project together. It's been an incredibly fun working with Mark and the rest of the AMD team.
Yeah, Mark and I share a passion for what we do together. I mean, we at AMD, we completely value our, customer collaboration, and Mark's given us great guidance. But what I want to add is we both share a vision of what does the industry need to do? So what might need to be, one company working with another, but what really requires the industry to come together? And that is rare to find, folks that really want to partner on going over and above and bringing the tide up so that all the boats can rise and how the whole industry can benefit. And that couldn't apply to any better topic than confidential computing.
You both have been very consistent in your focus on the customer, the downstream end user, and the benefit. So when you're talking about building up the ecosystem, it's a real demonstration of your desire for the world to be a better place through technology and the customer experience to be improved. And it's a real testament to the character of both of you gentlemen. I'd like to just jump right in. We'll start with Mark P. Kick off by giving us your high-level point of view on confidential computing.
Well, confidential computing's been a long time in coming because we've been thinking as an industry, how do we provide more security broadly to customers? And it starts with the cloud because you think about people wanting to run their applications in the cloud, that means it's leaving their control, leaving their immediate premise. So it's really the first application. And it's great being on your podcast with Mark Russinovich, because that's how I got to meet Mark and got to start working closely with him. Because of course, Microsoft Azure is a leader in understanding that need for security and really driving this confidential compute capability. I think Mark's incredibly articulate to probably kick off your podcast with even the definition of confidential compute.
Thanks, Mark. Yeah, so confidential computing, just fundamentally what it's based on is a hardware root of trust that creates an enclave or a trusted execution environment into which code and data gets inserted or loaded, and can provide a quote or attestation about what that code and data is that the code, the application can then present to a key management service or to another application that allows it to establish trust, give it a key to decrypt the data, and then that can get processed inside the enclave, free of visibility from the outside and also free of tampering from the outside. And the whole point of this is that you want to minimize what the code needs to trust to execute, and also provide this attestation that can allow another service to trust that it can decrypt and use that data without the risks of the outside environment, whether that's the operating system, the server administrator, the hypervisor even, or malicious insider or a hacker that manages to breach the infrastructure. The whole point in cloud like Azure is to minimize the attack surface for our customer data. And so we've been working on confidential computing for many years. In fact, it goes back a decade to when one of our papers on exploring early use of confidential computing for analytics coined the term confidential computing.
A lot's been rapidly changing with the advancement of AI, both in the ease in which people can adopt AI, but then also with generative AI, novel uses like for weaponization or attack vectors with generative AI. How has this changed the privacy and security landscape? Has the need for confidential computing and confidential AI evolved accordingly? And which either of you feel free to jump in on that one.
Well, I want to say, Mark and I have talked about this quite a bit. I mean, confidential computing has been steadily growing in adoption, but AI is the killer app because, you've got to know that you can trust your crown jewels, because what are you doing with AI? It's the knowledge base of your company, or it's your own personal knowledge base of information you have. So it's clearly the killer app. And I just want to, before Mark will talk more broadly about it, but I want to just even build on the earlier comment that Mark Russinovich made. So you think about this killer app of confidential computing. So if you're going to put those crown jewels and run it in the cloud, and you want to know that it's safe chased, it puts an urgency on what we just talked about a moment ago, in that you have attestation. So every device knows that they're talking to another trusted device, so your whole computing layer is trusted. But honestly, the other key to confidential computing, broad adoption, and this is what AMD and Microsoft have worked very, very closely on, is you can't put all these hurdles that people have to do to be able to run in a confidential computing environment. You need it to be run seamless. And so, you've got to have complete ease of adoption. Otherwise, you really limit. How do you have a killer app for confidential computing and have that application take off if it's not completely trustworthy and completely seamless to be able to adopt?
So confidential computing is fundamentally important to the security in general. In fact, I've been talking with Mark Papermaster about this for a while, that we call it confidential computing now. In a decade, it'll just be computing. And so, for example, in Microsoft's own infrastructure, we're adopting confidential computing, starting with their trusted computing base of Azure and moving into other services, including things like our payment systems. I completely agree with Mark that AI is the killer app. And if you take a look at different AI scenarios, whether it's training or fine-tuning, the data that is going to go into training or fine-tuning can be of very high value that you want protected. The model itself that comes out of the training or the fine-tune model is also very high value, and you might want to protect it with confidential computing. And on the inference side, using the model, the data that goes into the model and the data that comes out of the model is also going to be very high IP. A great example is in speech transcription, where the data goes into the model and that speech can be extremely sensitive. And you want to make sure that whole process of the inputs and outputs are protected end-to-end with confidential computing. And then finally, another scenario that is relevant for AI is multi-party computations, where you bring multiple data sets together and from different parties and compute on them, train a model on them. And it's the killer app because of the sensitivity, the value of the data, the value of the models, and also the fact that the architectures for these different use cases are fairly structured and universal. And that means that there's not a lot of variability, and you can design a system with confidential computing specifically for it that protects that data end to end. It's much simpler than IT kind of workloads, where every workload has its own specific way of data flowing and what's sensitive data versus non-sensitive data that you have to go design a system if you really want protection on a case-by-case basis.
And the point you make about data and models is a really critical one. We see often with our enterprise customers and large organizations that they get stuck, their AI projects get stuck in pilot because they'll do an internal pilot project with sensitive data, which is, of course, the most valuable data in most of these situations. But then when they move to production, they have concerns about, well, how do we ensure that the data's not going to leak, that we're going to retain the ownership of the data, or, as you pointed out, the ownership of the model. So this being the killer app is totally consistent with what we're seeing in the market. In my 20-something year career in tech, I've never seen technology with such tailwinds in terms of driving adoption. You guys are old hat in the confidential computing space. I've been in it for a year now, having joined OPAQ a year ago, but it's been remarkable just what the pickup and secular tailwinds have been in driving this. So what innovations can confidential computing and confidential AI unlock? Are there potential impact on the economy and society? Mark P., do you want to start?
Well, you talk about autonomy. It's one of the drivers of confidential compute, because to have trust that we talked about earlier, that you truly safe chasing your data, your models, this incredibly sensitive information. The question is, who has control? Mark talked about earlier that this is not just the data that is being computed or the models that and the algorithms that you're running that are being encrypted. It extends the boundary of trust extends to the hypervisor. In fact, it was a tough bar. We were very proud at AMD. We came out with secure encrypted virtualization. So that meant the data or the models or any application that was in computation, data in rest, data in motion, we encrypted it. But in our first pass, Mark and the Microsoft team said, not good enough. You need to extend that trusted boundary to be the hypervisor, because you can't even have the administrators have access and be able to be, have a rogue agent. So that trusted boundary had to extend. And then I don't think people realize that the key, what really unlocks, for instance, a sovereign government from saying, why is it that I can trust that I can run in the cloud and not on-premise application, is that the keys are held in key servers by the end user, not by a cloud provider or or the administrator of even an on-prem installations being done. So when you talk about how does it unlock, it's frankly unlocking the very basic needs for some sensitive use cases. And so it unlocks the innovation of how computing can be deployed, because without that foundational trust, you cannot run your applications where you have sensitive needs.
That's a great point, Mark P. Mark R., would you like to add on to that?
Yeah, I think I touched on this with one of the scenarios, which is the multi-party computation. But I think when you talk about value that that confidential computing is going to unlock, specifically in the AI space, besides just security and supporting these sensitive workloads, I see that it's going to unlock enhanced privacy for consumers, for example, in the advertising space, where it's a multi-party computation by definition, where you've got retailers that want to sell targeted ads to consumers, and then you have the advertising platform. In the case of, for example, a retail bank that issues credit cards, now you have the bank credit card information mixed with the retail information and consumer history, and you want to protect the privacy of all the parties. Multi-party confidential computing clean rooms can support that and provide the kind of privacy that I think the whole world wants. But then you take a look at specific domains like healthcare or finance or government, and multi-party computations and the value that will be able to unlock when you get past the hurdle of, I can't share this data with the other parties. It's very sensitive data. It's high IP data, but I want to combine it. I would love to be able to combine it with these other parties so that we can get shared insights that from combining our data, whether it's coming up with a new pharmaceutical and it's drug trials, or it's coming up with looking for fraud and cross-border payments. All of those are multi-party computations that are very difficult today because of concerns about data leakage and data privacy and even regulation that I see confidential computing being able to unlock.
Yeah, just on regulations, Mark. I mean, think of the regulated industries like finance or medical applications, HIPAA. Without those assurances, those applications, frankly, couldn't be run in a trusted manner.
Absolutely.
So what you guys are saying is consistent with what I'm seeing. The thing I'll add to what Mark P said, which he said the optimal word, which is control. When I first started in this category, learning about it, the first thing that came to my mind was security, regulatory compliance through privacy. But what's turned out to be the compelling event that's driving a lot of customer adoption that I'm seeing is the ability to control the data unlocks new business models. So Mark R, talking about multi-party data collaboration, in those scenarios, the data is so sensitive in a lot of these scenarios. Let's say it's bond trading data from the last 4 decades that a particular trading firm has, and only they have. They wouldn't dare share that with other parties because then they would lose the ability to monetize it. But this creates an entirely new business model where, by virtue of confidential AI, they can share the data without showing it, doing confidential analytics or machine learning on the data with their partners, and they're able to monetize the data in perpetuity, effectively leasing the data rather than doing a one-time sale. So there's a lot of these new business models that are being created by the ability to control the data that seems to be creating the compelling event above and beyond, like even more than the security or regulatory compliance. Like that's important, obviously, but it seems that the pace and demand for adopting AI is creating these new business models that confidential computing is creating that's really exciting. So one of the things that this also unlocks too that I've seen, and there's recently a music label that's now suing all their distribution partners because their distribution partners have collected data that's now going to disrupt their business. So in the scenario, in like the before time when there wasn't access to confidential computing and organizations could not control the data with their distribution partners or supply chain partners, the next 5 years are going to be pretty wild because this data it's like the toothpaste has been squeezed out of the tube. There's no putting it back in. And there's going to be a proliferation of these companies that are going to get disrupted by their distribution partners, supply chain partners, and they're now clamoring. Are you guys seeing this in your businesses on Azure, Mark R? Are you seeing companies clamoring for this now?
Clamoring for control.
Confidential, being able to control the data,
Yeah, absolutely. And, Mark Papermaster talked about the sovereign cloud, which is like a macro example of what you're talking about. Sovereign clouds, by definition, are governments that want to protect and control their data that they're processing for national security purposes. And so that's just a macro scale of what you're talking about in the corporate space of wanting control of data and wanting to make sure that it's only used for whatever you want to use it for. And you want to protect it for the value that data has and the monetization capabilities that you get from all the investments you put into even getting that data and generating that data. So that's absolutely what's driving a lot of the business cases. that are out on top of the security cases that are driving adoption of confidential computing.
The European Union's an organization that we work with around emerging cyber threats at Opaque. And as you pointed out, it's under the umbrella of the sovereign cloud term. What's interesting is historically, sovereign cloud meant its physical location. The data center was located in a country. But in this scenario that you guys are talking about, the sovereignty of the data is determined by who owns the encryption key.
That's the fundamental shift. That's if anyone listening to this takes away one thing, that's the fundamental shift in control. Is once you see a broad adoption of confidential computing, as Mark said, eventually all computing will be of this ilk. The controlling point is the keys. When you have the keys, you are in control of the content.
Yeah, and I think from a practical technical control perspective, it doesn't matter if the data center is in country X or country Y. Of course, as you know, Aaron, I'm sure that laws are concerned about which laws are applicable to a particular data center. It depends on which country it might happen to physically reside in, unfortunately, which kind of interferes with this. Yeah, technically, it's fine if it's in A or B, but that's what we strive for. And with the design of confidential computing systems, as with Mark and as an industry, is to get to the point where technically it doesn't matter.
And I know this is obvious to you gentlemen, but let's play that through. Let's say that under the old definition of sovereign cloud, it's running in Germany, but that data does not stay in Germany, right? Obviously, that data is flowing all over the globe, depending upon who's accessing the data. So under the definition of sovereign cloud that's become commonplace today, it's kind of silly to say, oh, well, it's running in this data center in Germany, but people are accessing it all over the internet. So of course the data is flowing all over the world. With this approach of sovereign cloud, with this updated definition of sovereign cloud, you actually have control over who can see the data, where it's seen. And then it gets into what we were talking about with attestation, which why don't Mark P., why don't you talk about the importance of audit trails and attestation?
Oh, thanks, Aaron. And, first off, one thing to note is that the way this all works is the industry actually has to come together and collaborate. And so what you all have to know is that this isn't a problem that any one company can solve, because what is attestation? It means that you are verifying the authenticity of every aspect of the supply chain, the compute supply chain that's solving your problem, whether it be running your AI application or any compute application. So it's a very broad task to provide that trust over that compute supply chain. So I'll start from an AMD point of view, because we're at I'll say the start of that food chain. We're the silicon. That's where your competition is running on the silicon. So we got very, very involved in starting to work with Mark and Microsoft and the other big players in the industry with the root of trust Mark mentioned earlier, the very basic attestation of identifying who you are and why you can be trusted. But we're moving beyond that. We're moving to extend that attestation and attestation services so that you can trust exactly where that silicon was built, and you can have an audit trail that can be stored in an immutable record. And we're actually building off of work that Mark and others started at higher levels of that supply chain of computing, because it's not just the silicon. You need to know the firmware is trusted and that the applications are trusted. No rogue elements would be there. So, I think it's what you're seeing over the next 5 years is building on the start that we have on confidential compute, which is really about truly encrypting data and controlling the keys, and now augmenting that with an attestation that's going to be incredibly robust. And Mark, you've been driving a number of details of this chain of trust. Maybe you could add your point of view.
Yeah, well, this I think really excites me is the end-to-end vision for confidential computing, because we've been focused on the deployed application. But to really trust the deployed application, you need to understand where that application came from, who checked in the code to that application, how was that application built, and even what hardware is it running on is part of the chain of trust. And then how was that hardware built and created? All goes into a full end-to-end vision of understanding the provenance from a byte running in production all the way back to a developer checking it in, from a transistor in production all the way back to the design documents, the RTL that went into the fab to create that transistor. And we've started on this journey. It's going to be a long journey, but if you take a look at this, what this is going to provide to us, it's clearly necessary, and clearly there's certain risks and threats and breaches that have happened that if we'd had this kind of chain of trust and full visibility, transparency into that full supply chain of compute, we would have been able to mitigate them or understand them better after the fact in going and doing the post-incident analysis. This is kind of the end-to-end. It's like confidential computing application, but everything that went into that is built on top of an integrity chain that is, of course, constructed with confidential computing. Because when you have the build service, you need to understand what went into the build and what came out of that build. And the only way that you can be assured of what exactly that is to run the build in confidential computing, where it can do the attestations, the measurements of what went in. So this is kind of the full picture when we talk about confidential computing. We've been, again, very focused on, you're running in confidential computing. But the vision of confidential computing is full integrity and attestation and provenance end to end through the whole life cycle of every piece of code.
You're talking about a very large macro trend that will require the entire industry to adopt, which is exciting. And I want to drill into that a little bit more. What Opaque does today is a very small microcosm of that. With Opaque, we're building on AMD and Azure, and we're allowing our customers to create what we call jobs, write code, train models. And we're attesting that the data policies are intact through a cryptographic signature provided by AMD, for example, combined with an audit trail that they can then, any third party or any of the collaborators can verify and prove unequivocally that their policies are intact. Similarly, when it comes to the logic, we can do attestation of the logic. But Mark, you're talking about something much bigger here. You're talking about being able to protect like the entire global software supply chain and hardware supply chain that would prevent bad actors. So I think you need to like drill into that a little bit more, because I'm not sure it's immediately obvious to the casual listener who's new to this. You're talking about each independent software vendor working in collaboration with hardware manufacturers. Talk a little bit more about that.
Well, let me give you, for example, somebody inserting a piece of code in the build pipeline. You can put in, the best practices today for securing a build pipeline. Like, it's off the network. Here's the images that go into the OS, that's the build environment. But today you're just kind of like hoping that that's actually what happened, that it didn't talk out through the internet, or that what you thought was in the image was what's in the image. With confidential computing, you can know exactly what's going in the image. You can actually make it so that the build doesn't kick off if there's something that shouldn't be in the image is in the image. And after the fact, you have a record of what exactly was in the image. So maybe something did get through further upstream. You have this audit trail now that is a guaranteed audit, cryptographically provable audit trail of what went in. So after the fact, if there was a problem, you can go back and say, oh, here's where it went in. And then Mark has been thinking deeply about the hardware side, up until where it connects with software, which is the firmware of the hardware. But he's been thinking about from the firmware on down into the silicon and the fab, and tracing it all the way back to his, AMD's design artifacts that go into the fab, so that he can do the same kind of traceability. And Mark, you want to elaborate a little bit on that?
Yeah, you think about a lot of federal requirements require actually an assurance that in no way in that silicon build, as from Mark, I'll go with Mark's direction, from the firmware right down to the transistors, how to ensure that there is no tampering in that approach. And the way that that's done today is extremely expensive, so it really can't have a broader application. The way that's done today is, you imagine you wall off a semiconductor fabrication. You call it a trusted foundry, and so you put additional checks at every step of that manufacturing. And that serves its purpose, but it's not going to scale. And so to scale, what we're working on, and again, think about this as phase 2. It goes beyond confidential compute. It goes to true silicon through software provenance. What we're doing is capturing the data that's down to the transistor level from what it is we as the designer captured the design intent, and creating auditable records along the way that again check that not a single transistor could have been altered. And you extend that process. You store the auditable records, and you keep it actually in an immutable record. And so indeed, at the end of that hardware build chain, you can validate that there was no change whatsoever from the original design intent without having to build it in a fortress. That's what gives you scale. And again, you can do the same thing for the firmware levels. You can create an immutable record that exactly identifies to the line of code that it indeed is the latest. And it may not be that you're just creating tamper-proof. I mean, it creates now a chain that can say, well, let me make sure that I actually have the latest level of firmware, that I'm not missing a patch that went out. That data now is imminently available, including the records all the way down to the silicon, making sure that there was no news that came out of any risk associated with any silicon that was sent into your computing fleet. So it gives you assurance. And moreover, as Mark said, it gives you this, this entire record and chain and record that were there to be a concern or even a potential concern, you have the data to ensure that you've maintained a completely trusted compute environment.
So this would be a tremendous advancement in our ability to secure our hardware and software supply chains and prevent bad actors. Like, this would be a tremendous move forward.
This is going to start with the root of trust for confidential computing systems first, which includes the hardware for confidential computing, as well as the software that's the base of confidential computing systems, which mean key management service, attestation service. And because you have to have these secured that way first before you can start to build things, this trust chain that extends from there. And like I said, I think over the next decade, and it's tough to guess how long this is going to take, with the industry moving together and ecosystems adopting this and standards being defined and implemented, that eventually this will encompass all software. And again, it won't be, confidential computing is the only thing that's doing this, but software in general. You wouldn't think of not having attested builds that are running in confidential computing, that exactly what went in, what came out, and silicon it's been recorded, the artifacts in an immutable ledger with attestations all along the way. And by the way, immutable ledgers are a key part of this, which again provides you this tamper-proof capability, so that once something's there, it's there forever, and so you can guarantee that you can go audit it. But that's the journey that we're on.
So you're touching on my next question, Mark R., which is, what's going to make it flip where confidential computing is just so seamless to end users that they just naturally adopt? And before I throw that out there, one of the things that I've observed as a newbie to this space is a lot of misconceptions about the potential performance hit from confidential computing. So I want to start there before we get into, because I know that's one of them, is just the misconceptions about confusion around, oh wait, your encryption in use, is this some kind of cryptographic scheme like homomorphic or multi-party computation that is runtime complexity is too onerous for us to deploy at cloud scale? So first first part of the question is I'd like to invite both of you to talk a little bit about the performance. And then I want to talk more deeply just about making this seamlessly adoptable for end users, whether you're an ISV vendor or a company. So performance first. Let's start from the root of trust. Mark P., you want to go first on that?
Well, sure. I mean, when you think the attestation itself of that is not a performance hit, because your device attestation is going to occur, at boot time or checks along the way under the cover. So you're not going to see any hit there. But for confidential compute, it is an encryption process, and we have built it in. One of the things that was very, very important for us at AMD was to do two things: to make sure that that the overhead of the performance was low enough that it would not be a detractor, and then secondly, that it would not require software application modification, because either one of those would prevent adoption. So we've made great strides. I mean, Mark is our customer. I'll let him comment, but I mean, our goal is to have this, be always just, a very, very few percent, but eventually we want it to be almost unnoticeable of a performance impact, so that it just can't affect your buying decision. And that's the kind of requirement that Mark and his team has put upon us. And Mark, you're our customer of that capability. You should comment.
Yeah. So this has been part of the evolution of confidential computing with Mark and AMD, which is getting it to the point where it's what I consider no excuse, no friction confidential computing. And some of those things are performance overhead, which we've been driving down generation over generation, and we're line of sight of being very close, within a couple percentage points of non-confidential workload. And when you're talking about a couple of percentage points, you should just do this, like the way that everybody adopted the couple percentage points of hit encrypting all their network traffic for security benefits that gives you. Then there's some other limitations, like the impact of an update, which is bigger impact because you need to get the device into a secure state, because the whole point is preserving that trust boundary. And so we can't wait, to patch the server every 6 months. If there's an issue with the confidential root of trust, we need to patch it immediately. We need to make sure that doesn't impact the workloads either. And so we've been working with AMD on that. The scalability of it is another one. So this is when you get into AI, and we've been working closely with NVIDIA and AMD on scaling GPU and accelerators so that it goes beyond a single accelerator to a server full of accelerators to a whole colo of data center of servers connected together confidentially. So I actually, when you talk about we in 2020, we came out as Microsoft and said Microsoft will be a confidential cloud in 2025, built on the foundation of Azure. I think that in spirit, we're going to land about there. And by spirit, I mean, at that point, working with AMD, NVIDIA, and others, that every single server, every single device we put in our data center will be capable of confidential computing, and we'll have no reason not to use it. And so we're right at the cusp of that. And that's really when, combined with the software enhancements that we're building and the ecosystem of things that we've talked about are landing, that's when we're getting into you should just be confidential.
Realizing that the performance overhead is single-digit percentages, just a couple of points, that clearly removes the barrier for people to deploy with confidential computing. What else do we need to see for confidential computing to become seamless? Like, where do we start seeing applications architected for confidential computing? And credit to AMD, you guys have made it very easy, but to actually run your applications attested and your data and models, like in the AI space where we are, you have to, it's not just putting it in a CVM. There's more work to be done there. And you've made it very easy, but there's a little bit of a lift. Where do we need to be so that we see more seamless adoption for people who are building business applications and then downstream end users?
So we do have an immutable ledger we built in Microsoft. It's open source. It's built on confidential computing. We're in the process of migrating it to SNP so that it's available there as well. It's called Confidential Consortium Framework. And that is actually what we're using internally. We've got the service called Azure Confidential Ledger that we're using. So this technology, it's been in production for several years now. So our confidential immutable ledger is actually production grade at this point. And that's the foundation for all of the things that I've been talking about we're doing in terms of supply chain security inside of Microsoft. I think that the other thing that needs to happen is these constructs that make it easy for developers to build applications need to be there and build it in a truly confidential way. Today, you can launch a confidential virtual machine and you get some defense in depth there, just running your app and OS unchanged. But you don't truly get all of the promises of confidential computing, which means, hey, my data is truly protected. For that, you need to put in more controls. So, for example, I don't want a guest agent, an agent like a monitoring agent or a security agent to be able to leak my data out of the CVM. So one of the things that we've been doing with a focus on the future of cloud computing, which is containerized, we've been designing policy systems for confidential containers. And we've actually already launched this in production in Azure as confidential Azure container instances that come with policies that are enforced inside the container runtime to prevent things from leaking or it being tricked into doing things like leaking data. And that's just one example of kind of the ecosystem software work that has to happen to make it easy for somebody to get the benefits of true benefits, realize the full benefits of confidential computing, but do it in a way that they don't have to go reinvent the wheel themselves and architect everything from scratch. So these layers of functionality that are designed for confidential computing been coming online, and that's what's going to unlock the ability for somebody to just say, I'm going to make this thing confidential. Here's the policies that I defined, because you need a policy for what the thing can do and can't do to realize the benefits. But this maturation is rapidly happening.
Just to elaborate on what Mark's saying, you have to architect how you're running in the way that Mark described. I mean, this is what data center architects do. When you create applications, you've got to, am I running containerized? How do I architect that container? And so that is, think about a SaaS application that's running in the cloud. I mean, you're going to architect both for your best compute efficiency, but also to ensure that you've maximized any protection from data or algorithm leakage, as Mark described. But key from us, from a compute engine standpoint in AMD, whether it be our CPUs and our GPUs, is that we've collaborated in the industry so that we have standards of how that we're interoperating in that trusted boundary, again, such that the actual application, the software application itself, doesn't have to be modified. So what's important is that we enable users to architect how they're putting their compute infrastructure together, but that the code itself should be able to be run unmodified in a confidential compute application. That to me is very key to ensure there's not barriers to adoption.
Yeah. By the way, Mark, thinking about ways that the industry's come together to, have everybody interoperate so that we can realize this vision. TDISP is one great example where we working with you and others and all of us working together to define this standard on top of CXL so that CPU can connect to a GPU in a secure, trusted way that's confidential. That has to be an industry standard. Otherwise, we just can't do those kinds of things.
And it's coming out to market now. And so you look at our new 5th gen EPYC servers. They support TDISP or Trusted I/O, and so that confidential computing boundary can now extend from that CPU complex itself, as Mark said, out to GPU accelerators, but also out to storage, memory extensions with the Connect Express link, et cetera. It's very exciting advancements for our industry and based on industry collaboration.
So this is really important work that you guys are doing, in particular because whoever controls the data will control that industry. And with that, of course, I mean the models too. So being able to verify, have auditability, and proof that your data policies are intact and your model and data sovereignty is intact is just critical for all businesses. Over the next 5 years, it's going to be wild because there's going to be companies that really struggle because they didn't control their data. And this technology will secure their future. As we look over the next 5 years, though, and if you could wave a magic wand, what would the world look like in 5 years? And we'll do Mark B, you first. Relative to confidential computing, of course.
Yeah,
we'll keep it narrow.
I'm a compute guy at the base of this compute supply chain. So my view is that if you look out 5 years from now, we absolutely have not only gone to phase one that we're in full production on today of confidential compute, so that that compute complex is encrypted. It protects against, it includes a protection on malicious hypervisors. We've now gone to phase two, as we just talked about, Mark and I, with extending that trusted boundary with the TDISC standard, with Trusted IO. Again, using standards to make this seamless. And so when I look out 5 years from now, it's that it describes to the vision Mark put out earlier, that this is just the mode of computation that everyone's running in as they trust their cloud computing, but that we've gone beyond that. This need for confidential compute extends from the cloud to the edge, to devices like PCs that I'm using to join in on this podcast today. And so 5 years from now, I see this trusted boundary becoming seamless across not only our supply chain and extensions in terms of auditability that we just described, but also extending beyond the cloud.
I should have given the hardware gentleman the 10-year wand, and Mark R, the 5-year wand. But the important things that you said that really stood out to me was hardware supply chain, auditability, verifiability, and the edge. Like, there's a lot of exciting things that are going to be happening on the edge. Mark R, your turn. 5 years out.
I think Mark captured it really well. I mean, if I could wave a wand, it would be, we realized the vision that we talked about here, that we can move quickly enough that in 5 years, the world is confidential, and the confidential trust boundary goes from client devices into the cloud. And it doesn't matter where the data is, it's protected in the same way throughout its whole life cycle and every stage of in transit, at rest, or in use.
Thank you both, Marks. This is not just an interesting conversation, it's a super important conversation. This is very important, what we're talking about here. And companies that do adopt these new technologies are going to differentiate themselves in the market. And those who can control their data and models are going to be healthy, thriving businesses into the future. And those who struggle are going to struggle to stay in business. So thank you so much both for taking the time here today. It's a real honor.
Thanks very much.
Yeah, thanks for having us, Aaron.
Thanks for tuning in. If you like the show and want to learn more about these topics, check out the website, opaque.co. If you like the podcast, please leave us a review on Apple Music or wherever you get your podcasts. We want to hear from you. This episode of AI Confidential was produced by Opaque, the leading confidential AI platform. I'm Aaron Fulkerson, and I'll see you next time.